We're recording. This is a test of the American Broadcasting Service. A train, so all of these are based on the idea that rate times time equals distance, right? If you travel 20 miles an hour for 2 hours, how far do you go?
200 JK.
20 miles an hour for 2 hours, you go 2 times 20, which is 40 miles, right? Okay, so that's, you should know that formula because all of these problems are based on the fact that rate, where's my writer? That rate times time equals distance, all right? And so these problems, they can be a little bit tricky, but if you kind of keep that in mind and you fill in these tables, it should help you to solve these problems, okay? The first one says, a train leaves a train station at 1 p.m. It travels at an average rate of 60 miles per hour. A high-speed train leaves the same station an hour later. It travels at an average rate of 96 miles per hour. The second train follows the same route as the first train on track parallel to the first. In how many hours will the second train catch up to the first train? So probably in here what you want to put is train, first train. And here's the train, the second train. Train the first, here's the second train. How fast is the first train going? 60 miles per hour. How fast is the second train going? 96. That's pretty fast, right? Okay, now you're trying to find something. They don't really tell you anything about the time, okay?
Yeah, it does. It leaves at 1 p.m. and then the second one leaves
An hour later. So whatever this guy, and eventually this guy catches this guy, right? So think about it. Sometimes the other thing that's useful to do is kind of draw pictures of the situation. This guy, so here's train one. He starts and he's moseying. He's going the wrong way. Don't go that way. We want him to go in one direction, okay? So he starts up here, he's moseying along, moseying along, moseying along. And while he's going, after 1 hour, this guy starts, and eventually he catches him, okay? So who goes more time, the first train or the second train? The first, right? Because he got to 1 hour earlier. You understand that? Okay? So if I call this guy's time, say this guy's time is, I could either call him T and him something else, or I could call him T plus something. If he went T time, whoops, I don't want an arrow on there. Okay? If he went, I don't want arrows. No arrows in it. Okay? If this guy went T, a time of T, and this guy went 1 hour more, how much time did he travel? What's 1 hour more than T time? T plus what? 1 hour more than T.
T times
1 hour more than T is T plus 1. Yes. T plus 1. Come on. It's T time. No.
2. I see what you mean.
It's T time. Do you understand that? So if this guy goes for T, this guy goes for T plus 1. If this guy, you could have called this guy T, then what would I have to call this guy? T minus 1. Okay, so I like using plus whenever I can versus minus. So I could have called this guy went for T hours, and this guy went for T minus 1 hours, but I prefer, since I like positive numbers, to do this. So the distance, this is rate times time. Uh-oh, it's freaking out. Shaking. Rate, why is it shaking like that? Stop. It didn't take its meds today. Okay, stop. Why is it doing that? Weird. Maybe it's not me. Maybe I drank too much coffee. I don't know. So rate times time equals distance. So the distance traveled, you write this as 60 times T plus 1. Okay? And this guy went 96 times t, or just 96t. Okay? So this is his distance, and this is his distance. What is true about those two distances when they meet? How far did they both travel? Did they both travel the same amount when one guy catches the other guy?
Yes.
Yes. Here, look. We have to model this. Wait. We have to pause. Pause. Then that means that 60 times t plus 1 must equal 96t. Okay? And then I do my math. I do distributive property. I need some more room here, don't I? You know what I'm going to do? I'm going to take a picture of this. I'm going to make the whole thing bigger. Okay, so now I have more room. So now what I'm going to do is I'm going to multiply this through, so I get 60t plus what? What's 60 times 1? 60 equals 96t. Now what? I got to get this over onto here. How do I do that? Subtract 60t from both sides. So I'm going to go minus 60t over here and minus 60t over here. And now I get 60 equals 36t. And then what? Divide by 6. 6? Divide by 36, right? Divide by 36, divide by 36. And I get t equals, this goes away, 60 divided by 36. So then I need a calculator. Uh-oh. I could do that. Where's my calculator? Here, calculator. Hold on. There it is. Okay. Look at how high-tech I'm being here. Okay. And I'm going to go, make it clear, I go 60 divided by 36, and I get 1.666666, okay? Which is what? Not exactly 0.7. Uh-oh, what happened to my stuff? Is that it? It's not 0.7, it's 1 2/3. So that's 1.6 repeating, which is 1 2/3 hours. Okay? And it says, how many hours will the second train catch up? That's the answer, because we found t, right? So that's how we do it. What's wrong, Brian? Yeah, me too. Okay, so next problem. We're going to go on. Sorry, but we got to go on. So now we're going to learn about, what are we going to learn about now? Peter. Peter drives into the city to buy a software program at a computer store. Because of traffic conditions, he averages only 15 miles an hour. On his drive home, he averages 35 miles an hour. If the total time is 2 hours, how long does each take him to drive to the computer store? So what you want to do over here, part of Peter's trip, you want to be going, you want him going, and you want him returning. What's his rate going? 15. Okay? What's his rate returning? 35. Now here's where it gets a little bit tricky. Okay? If I how long does it take him to drive to the computer store? So let's set up a variable. Let's let t equal, since that's what we're trying to find, how long does it take him to drive to the computer store? Let t equal time to store. Okay? So I'm going to put in a t over here. So here's the tricky part. If the total trip is 2 hours, and it takes him t hours to get there, how many hours does it take him to get back? not T. It's not the same, right? Okay, again, think about this. If I have $100 in my pocket, I give Jordan $25. How many dollars do I have in my pocket? 75. How do you find that? Subtract it, okay? So if I have 2 hours in my pocket, okay, I give Jordan 2 T hours, how many do I have left? 2 minus T. So the leftover part is your original minus T. So this is going to be 2 minus T, because that will give you what's left over. So again, rate times time equals distance. So you know that this is 15T. And this is 35 times T minus 2. 2 minus T. Sorry. Is the distance going the same as the distance returning? Did he go the same distance this way as this way? Yes. Okay? So you can make those two things equal to each other again. Okay? So we're going to get a new piece of paper because I'm running out. And you can't see? Am I in the way? There. Am I in the way now? Okay. So now, what you want to do is set up this equation such that, okay, 15T equals 35 times 2 minus T. Excuse me. And then you do just what we did in the last problem. 15T, you multiply 35 times 2, which gives you 70. 35 times minus T gives you minus 35T. How do I solve that? Not subtract 15, because you want to get, then you'll end up with negative on this side and 0 on this side. How do I get this 35 over onto that side? Go ahead. Thank you. I add 35 to both sides. So I add 35T to that side, and I add 35T to that side. And I get that 50T equals 70. And then I divide both sides by 50. Divide by 50. Divide by 50. And I get that T equals 70 over 50, or 7 over 5, which I'm not going to use my calculator. That's 1 2/5, which is equal to 1.4 hours. That's how you do that. So that's how long, what is that, how long? That's how long it takes them going, and coming back, it only takes them 0.6 hours. See? So it's going way faster now. So the next one looks like Donna and Noel. They still go to school. No, they don't go to school. They graduated. This is, oh, thank goodness. No, we're just, oh. I'm just kidding, Donna. Okay. She knows me. Anyway. Noel graduated? I think so. Alright, so I made up this problem a couple years ago when I had Donna and Noel in there. Okay? Donna and Noel leave school traveling in the opposite directions on a straight road. Donna travels 15 miles per hour than Noel. After 3 hours, they are 225 miles apart. Find Donna's rate, find Noel's rate. So this one is a little bit different, okay, in that they don't go the same distance. One person is going this way, and the other person is going this way, okay? And after so many hours, they're going to be, after how many hours? After 3 hours, they're going to be a total of 225 miles apart. So that's going to be 225 miles, okay? It's not that much harder, okay? So here we have Donna, and here we have Noel. And in this case, we know both of their times, they both travel the same amount of time. How much time do they travel? Hello? they both travel the same time, 3 hours. Okay? And this person's rate, Donna, I'm just going to call her rate R. No, I'm going to call Noel's rate R, because Donna is 15 miles an hour faster than Noel. And so R equals Noel's rate. Okay? You get that? Noel's rate? And so if she goes 15 miles an hour faster, what's Donna's rate? Ah, very good, Jordan. R plus 15. Okay? The distance she traveled, Donna, is 3 times R plus 15. Okay? And the distance that Noel traveled is 3 times R, or just 3R. Now, this is the only difference between this problem and those other problems is you don't make these two equal to each other. They add up together to 225. So the equation that you can write is 3 times R plus 15, because that's the distance that Donna travels, plus 3R, because that's the distance that Noel travels. What does that have to add up to? 225 is the total distance that they travel. Okay? Now we're going to solve this for R. Okay? So I'm going to go multiply, distribute, 3R plus, what's 3 times 15? 3 times 15. Who knows 3 times 15? Thank you, Lydia. 45 plus 3R equals 225. I'm going to combine my like terms. 3R and 3R make 6R plus 45 equals 225. Okay? And then I have Mr. Evans.
What's up? Keys.
I named my keys already.
You probably made a mistake.
Okay? Recording. We're going to subtract 45 from both sides. Okay? Because I'm going to be a YouTube sensation after this video. Okay? 6R equals, I'm going to go viral. Okay? 180. And then I'm going to divide by 6. Divide by 6. And I get R equals, what's 180 divided by 6? What's 18 divided by 6? 3, add a 0, right? So Donna's rate, was that what we were looking at? Noel's rate is 30. What's Donna's rate? She goes 15 faster. 45. And then you're done. Okay? So 30 miles an hour, 30 mph, and Noel is going 45 miles per hour. But that wasn't the question. They asked you what's Noel's rate. So that's the end.